Hello, students. This week we're looking at scatter plots. That's our topic. Now, scatter plot is a type of data display that shows the relationships, if there is one, between two numerical values. Each member of the data set gets plotted as a point whose xy coordinates relate to its value for the two variables. For example, here's a scatter plot that shows the shoe size and quiz scores for students in a class. Because shoe size is labeled as the x-axis, that would be our independent variable, the thing that we could vary or manipulate. The score, being on the y-axis, represents our dependent variable. So looking at this, compare these two variables together, we're saying that we think shoe size might affect the score you get on an exam, or that the score depends on shoe size, which obviously makes no sense. So the data in this example is kind of all over the place. There's no clear linear pattern to it, which would suggest that there's no correlation between these two variables. So when we say there's no correlation, what are we talking about? Well, when the y variable tends to increase as the x variable increases, we say there's a positive correlation between the variables. So this first graph has a positive correlation. It's equivalent to having a line with a positive slope. Later on, we're going to be looking at the correlation coefficient, which is a way of measuring that. And that will also have a positive number if there's a positive correlation. When the y variable tends to decrease as the x variable increases, we see there's a negative correlation between the variables. So you can see in the second graph that the data is going down as it moves to the right. The first graph, it's moving up as it moves to the right because it's positive. In the second one, it's moving down because it's a negative correlation. In this original plot, we said that there was no correlation between the two. That's because the data isn't either moving up as it moves to the right or moving down as it moves to the right. You can make an argument that it's doing both at the same time. This graph is looking at the relationship, if there is one, between the age of drivers, which is our x variable or our independent variable, and the accidents per 100 drivers, which is our y variable or the dependent variable. So the question is whether the number of accidents per 100 drivers depends on the age of the drivers. In this particular case, the data clearly is going down as it moves to the right, which suggests that as drivers get older, they tend to have fewer accidents. This would be a negative correlation. When we describe scatter plots, we tend to look at the form, the direction, the strength, and sometimes we look to see whether there are any outliers. We're not going to focus on that part. We are going to focus on form, direction, and strength. So when we look at scatter plots, we should be able to describe the association we see between the variables. A quick description of the association in a scatter plot should always include a description of the form, direction, and strength. The form, is the association linear, or nonlinear, or non-existent? In terms of direction, is it a positive or a negative correlation? And in terms of strength, does the association appear to be strong, meaning that the points fall almost exactly in a line? Moderately strong, meaning they're kind of in a line? Or weak, meaning there might be a correlation there, but it's not really obvious. So let's describe this scatter plot, which shows the relationship between the age of drivers and the number of car accidents. As I said, in this particular case, it's a negative correlation. The dots fall pretty much on a line, so it's a strong negative correlation. And it's clearly linear. It doesn't show a curve or anything else that would suggest it's a nonlinear. So this scatter plot shows a strong negative linear association between the age of drivers and the number of accidents. Notice that this description also puts it into context because we are looking at the age and the number of accidents. So let's look at another example. In this, there is a strong positive linear association between the two variables. So which of these answers fits that? Well, A, it's a strong linear correlation, but the y values are going down as it moves to the right. So this would be a negative correlation. In B, there looks like there is a correlation that the numbers tend to go up as we move to the right, and they're kind of densely packed around what might be a line that goes through there, but they're kind of all over the place. So it would be maybe a weak or moderate, if at best, correlation. C, it's definitely a positive correlation. The y values are going up as you move to the right. It does look linear. There's not really an obvious curve to it. And it's fairly strong because there's a clear line that you could draw through that would reflect the data. So C looks like a good option. In this case, we're looking for a moderately strong negative linear association between the two variables. Well, the first one is moderately strong and linear, but the y values are going up as x moves to the right, so that would be a positive correlation. B has a very strong negative linear correlation. So if we look at C, the correlation is not quite as strong. It's still there, and there are a couple of outliers. The farthest dot to the right is off the line. That's what you'd call an outlier. But in general, the data follows a linear path, but it's not as close to a line. So that would be the moderately strong negative linear correlation that we're looking for. This one, there's a strong negative nonlinear association between the two variables. We're not going to focus on nonlinear, but there are a couple of obvious ones here. A and B follow curves. The first one is a negative correlation because the y values tend to go down as it moves to the right. And B is a fairly positive correlation because the y values go up as it moves to the right. C, if it's got any correlation, is a linear correlation of sorts, probably, but it's not very strong. So for this one, the strong negative nonlinear association would be A. In this case, we do want to put it into context. Cindy wants to predict how much energy she will use to heat her home based on how cold it is outside. The graph below shows the mean amount of gas per day in cubic meters that Cindy uses each month and the average temperature that month in degrees Celsius for one heating season. So which statement is the best description of this? Well, the data seems to have a fairly strong linear negative correlation. So the temperature increased. As the temperature increased, the amount of gas used increased. Well, clearly the amount of gas didn't increase. As temperature increased, the amount of gas used decreased. Well, that seems to fit our pattern, and that actually makes sense because you would use less gas to heat your house if it's already warm out. So we can pick that answer, and we'll see that it actually is the correct answer. Good job. So this concludes our quick review of scatter plots. I do want to point out one thing. If you notice, there are dots, points plotted on each of these graphs, whether it's a positive correlation or a negative one, and they don't connect the individual points. I noticed in the first packet that you guys turned in that several people connected the dots. That would be a line graph, or sometimes called a broken line graph, or a time series. In those, you do connect dot to dot. But in a scatter plot, you leave the points scattered. You don't try to make a connection. You also don't necessarily have to include the origin, the point 0, 0. That's not one of the data points given. It shouldn't be in the data. Okay, so have fun with this. This week we're going to be accepting this packet only as a scanned packet. There aren't equivalent Khan Academy exercises, but there are Khan Academy exercises that you can use to improve your understanding of the topic. So I just advise you do that. There also was not an easy way to have you creating the graphs online. Khan Academy does include one for that, but it leaves out having to label the axes, which you need to do, and having to give it a title. Every graph you do should have a title. So do this on the packet, scan it in, and turn it in on Teams. If you can't find a way to turn it on Teams, if that's not working for you, you can upload it to your OneDrive and share it with me, and I'll get an email that way. And if that's not an option either, then you can email me a scan of it. If you do a scan, make sure that you do a scan that produces a PDF file and that all the pages that you're sending me are upright. I cannot read the ones that are sideways. Thank you so much, and enjoy your week.